Hello, welcome to this video. In this video, we will be solving this graph question. This is a beginner level graph question. So here given a bidirectional graph with n vertices. So they asked us to find whether they also given a source and destination, whether we have a valid path that connects source to destination. So as such, for these graph questions, we can do DFS or BFS. Both methods work. In this video, I will be showing DFS. So for DFS, we will be using a stack. For BFS, we will use a queue. But without stack also we can do this by using our call stack. We can use our call stack as our stack and can solve this problem. Okay. So first let's represent this graph in an adjacency list. So adjacency list is a two-dimensional array in which we will have all the nodes okay. So basically this is one array. In that array we will be having multiple arrays. We can also use here map for doing this. For this particular problem we can also use index, as the nodes having 0 to n-1 values, and if we use an array we can index them. We can access by its index itself. So we can use an array of arrays for this one. So for node 0 we have two neighbors, 1 and 2. So okay, for 1 we have also two neighbors, 0 and 2. This is also a cyclic graph. So for 1 we have 0 and 2 as its neighbors. So this adjacency list is used to represent a graph, a node neighbors. Like humans, we can know, we can see visually how graph is connected, but for a program to know, we need to create such adjacency list. So our adjacency list is ready. So now what we have to do is, we also need one visited array. We have here three things, I mean three nodes. So we will be taking an array of 3. So this is my visited array. Okay. In problem, source is given at 0 and destination is at 2. So we will be starting from 0 and we will check. As we are doing DFS, we will go through first of its neighbors, 1, and we will check if 1 is equal to our destination, which is 2. 1 is not equal to 2, so we will dive into its neighbors. For 1 we have two neighbors, 0 and 2, so we won't be visit 0 again, as we already started at source 0. We will mark it as true, so we already visited 0. So and we have another node which is 2. 2 is not visited here, so we will go to 2 and we will check is source is equal to destination. Yes, source is here equal to destination, and we will return to. We can visualize this algorithm as like this. First, we in problem we will be given number of nodes, edges in 2D array, source and destination. So first we have to create an graph array. Here it is an adjacency list. So after that we need to add neighbors to the graph. This will be clear while we will be writing code. So while going through each of the node, we will mark visited array as true, and then we will start doing our DFS. First we will check is our source is equal to destination. If it is yes, we will simply return true and the program will end. If it is not, we will be checking all of its neighbors. So if the neighbor is visited, we won't be checking it. If it is not visited, then we will call that neighbor again with a new DFS recursively. If this DFS returns true, then we can return true, else we will return false at the end of the program, and it will end. So let's write code for better understanding. So yeah, first we have to create a graph. Okay, we will name it as graph, and we will create adjacency matrix. It is a 2D array. So this is an array method in JavaScript to create. So this above will create, our n is 3, so it will create this kind of 2D array for us. So now we have our graph structure. So let's add neighbors to it. So what we can do is we can loop edges, edge of okay, in edge we have two things. One is current node and its neighbor. So we can destructure it. We can call current node, and for neighbor. So now we have to connect them in this graph. So we can simply graph node push neighbor. As this is a bidirectional graph, so we also need to push in our neighbor's node and connect to this node. For example, we have 0 and 1. So in 0's neighbor there will be 1, and also in 1's neighbor there will be 0. So after this we have our graph. Okay, now let's create an visited array. So this is also an array method to create. So this will create n number of, firstly it will create an array of 3 slots, undefined, undefined, undefined. Later we will using this fill to fill it to false. Okay, so our visited array is also created. So after visited array, now we have to call DFS. I will pass visited source, destination, and if the destination is reachable, it will return true. I will return that answer directly from here. So let's add our DFS function. Okay. Okay. From algorithm, what we have to do first, we have to check whether the source is equal to destination. So if src equal destination, return true. If once we visit any node, we have to mark it as true. Okay, now we have to check all of its neighbors and do a DFS here. So neighbors. So this is graph. We have renamed it as neighbors. So to get our source neighbors, we have to include source here. So after that, first we will check is this node visited or not. If it is not visited, then only we will proceed to DFS. Otherwise, in cyclic loops, we will be going through an infinite loops. Here, instead of source, we will give our check with our current neighbor for DFS. If it is true, we will return true. Else, at the end of the program, we will return false. So let's check it. Okay. Okay. So some people may have thinking why we not use it for each or map. So this type of like for loop is like universal for C++ and Java. It will appear familiar for if you are giving an interview, it would appear familiar to the interviewer. So try to avoid for each while doing coding questions. So in development we can use for each and map. So that's it for this video. Hope you have learned something from this. So thank you for watching.